So we have one more lesson to cover here as far as Algebra 1 for the semester, and hopefully this video won't take tons of time. The only thing that we have to add to our process here is we're going to now include the issues of parallel and perpendicular lines. So this was an activity just to recognize, this is to recognize parallel lines, and we'll go and try to do perpendicular here in a second. But to quickly graph on this note packet is what we're going to do. We need to put each of these lines in slope-intercept form, okay? The first one is going to be shown below. So if you look below, we subtracted the 3x over. We divided by 4 and got y equals negative 3/4 x plus 3/2. And if we come down and look at this, they are graphing that for me right here. So that line has already been graphed, okay? What they're asking us to do is go ahead and solve for y and graph the other one. So I will choose a different color so it's not red. We'll go with orange. So again, we're going to subtract that 3x over. We're going to divide by 4 again. And this is going to be negative 3/4 x plus 3. So if we're looking at the difference here, now we're going to start at 1, 2, and 3. So we're going to start at 3 on my y-intercept. We're going to go down 3 and over 4. And that's going to, therefore, we're going to have a line shooting through there, and it looks something like that. Okay? The other one that they want us to do, we'll do that in a different color yet. We'll do that in green. So we'll have 3y is equal to a negative 4x plus 12. We'll divide by 3 and divide by 3 and divide by 3. So that means that y is equal to negative 4/3 x plus 4. So we're going to start it at 4 this time, except it's going to go down 4 and over 3. So it shoots through there something like that. Okay. Coming over to the other set because they want us to do it as well. So we'll go back to the red one because that's the one they did for us. We subtract the 5x over. Get in a hurry. We're going to divide that 2 out of there. So we're going to graph y equals negative 5/2 x plus 3. And if we look, that is what they graphed for us. So we already got that covered. And now, again, we're going to solve for y. So in this one, it'll be simple enough, except I want to do that in a different color. We'll go grab purple this time. So we're going to subtract the 2x over. So there isn't too much to this one. We're going to start at 3. And we're going to go down 2 and over 1. We're going to go down 2 and over 1 more. And so it's really similar, but it's not the same. Here, there wasn't a whole lot to that. Again, we'll change colors. Man, this is I don't like this example at all. But all right, so now on the green here, we're going to start at 5. And it looks like we're going to go down 2.5 and over 1. Down 2.5 and over 1. And so there we go. There's our line. Okay, now what we're supposed to look at here is we're supposed to look at what ended up being parallel lines. So if we look over here in our first example, the original black line and my orange line here are going to be parallel. And what they're asking us to do is to compare. So we want to compare this equation and compare this equation. What is the same about them? And hopefully we recognize that what is the same about them is, so if we write this out, this has a slope of negative 3/4 and a y-intercept of 3/2. This has a slope of negative 3/4 and a y-intercept of 3. So if we see here, they share in common, they have a slope of negative 3/4. So that's what the moral of the story is. When we scroll over here, another page, How can you recognize lines that are parallel? Parallel lines have the same slope. Okay? All right, so now what they ask us to do is they ask us to do something similar, except now we're going to recognize perpendicular lines. And we're supposed to do something similar, except with perpendicular. They changed up the equations a little bit. Actually, I think the first one of the originals, let's see, 3x plus 4y, 3x plus 4y, 5x plus 2y. Okay, they switched it around a little bit, so I won't go get too crazy on this. But here we go, the black line. We'll write this in black, because that's what it is. Okay. Again, we're going to subtract over the 3x. We're going to divide out the 4. And so we get y is equal to negative 3/4 x plus 3 halves. And again, that is the black line that we're doing down here. Okay, so that stayed there. In a different color, we'll do purple. Negative 4y equals negative 3x plus 12. We're going to divide by negative 4, divide by negative 4, divide by negative 4. So we end up with y equals 3/4 x minus 3. So we're going to start at negative 3. Can't hardly see it. But then we're going to go from there. We're going to go up 1, 2, 3, and we're going to go over 4. So that line goes there. Got a positive slope and a negative slope. So that's what we have there. Picking another color. I'm not sure how different blue will be, but we'll try it. Negative 3y is equal to a negative 4x plus 12. We're going to divide by a negative 3. And so we're trying to graph y equals negative, nope, not negative at all, 4/3 x minus 4. So we're going to start down here at negative 4, except this one's going to go up 4 and it's going to go over 3. And so we're going to draw that line through there. Okay, I didn't draw that very good at all, but again, we're trying to look for perpendicular. And so I'm just going to say that those are perpendicular because they're close. Okay. It just didn't quite get there as far as my sketching with a poor scale. Okay, so let's come over here and do the other one. We are going to subtract 2x over, and then we're going to divide out this 5. And so we end up with y is equal to negative 2/5 x plus 2. And we see that we have that equation down below. It's already being graphed for us. So now, again, if we jump colors, we'll go purple. All I have to do is add the 2x over, so that's 2x plus 3. So we start at 1, 2, and 3, except we're going to go up 2 and over 1. And so that's kind of there. And the last one here, we're going to do that in blue again. So I am going to subtract the 2.5x over. This y has to be positive, so we're going to divide by a negative 1. And so my final answer turns out to be, and what we need here is, I can't mix decimals and fractions. So I'm taking out the 2 halves. 2 halves is the same thing as 5 halves. And so really this is going to be 5 halves x minus 5. So we're going to go down here to negative 5. There's 1, there's 2, there's 3, there's 4, and then I'm thinking this is 5 somewhere in there. Okay, it's going to make that hard. We're going to go up 5, and we're going to go over 2. And that was actually a much better job. We can see that those are perpendicular as well. Okay, so what we're trying to do is we're trying to explore connect the dots between parallel and perpendicular. And again, it's tied into slope. Okay. So if I look at the slope of my black line, the slope of my black line is negative 3/4. If I look at the slope of my blue line, the slope of my blue line is positive 4/3. If I come over here, again, the black line, the slope of my black line is negative 2/5. And if I look at the slope of my blue line, the blue line slope is going to be 5 halves. So hopefully we can see the relationship between perpendicular lines We can see that one is positive, one is negative, one is 4/3, the other one's 3/4. Here again, we have positive and negative, we have 5/2 and 2/5. So when we talk about the relationship between perpendicular slopes, perpendicular lines, the slopes are opposite reciprocals. Okay, that's what we have to pay attention to. So, I gave the chase away. I'm not after questions 4 and 5. We'll just nix those out. But we're talking about parallel lines have the same slope. Perpendicular lines are opposite reciprocals. So, if we were to define that, these are two lines in the same plane. That do not intersect. These are two lines that intersect at a right angle. Now what we have to do is we have to be able to use the parallel and perpendicular to create equations of lines. Okay? And actually there we were given the definitions there. So I'm going to move on to the extra practice and get moving on with life. Determine which of the lines, if any, are parallel. Okay? Yeah. It's going to be labor intensive here. Okay? But this one's nice just because I can just count the slope. I'm just going to count the graph. So I'm going to go up. If I look at the black line A goes up 1, 2, and 3, and over 1. So the slope of line A is 3/1. Line B goes up 1, 2, 3, and 4, and over 1. So it goes up 4 and over 1. Line C also goes up 4 and over 1. So that means because B and C have the same slope, they are parallel. Again, if we go with A, we're going to go down 1, 2, 3, and 4, and over 2. Excuse me, down 4 and over 2. Line B goes down 1, 2, 3, and over 1. Line C goes down 2 and over 1. So this simplified into a -2. This simplifies into a -2. So in this case, line A and C are perpendicular. Excuse me. I don't know what am I doing. They aren't perpendicular, are parallel. Because slopes are the same. Now, when we get to 3 and 4 and 5 and 6, that becomes very much labor intensive. Because looking at those, I have to determine the slope between all three of them. Wow. Anyway, so we have to do the slope between A and B. We have to do the, sorry, what am I doing? Back up. We're just doing a slope here. So line A. -1 minus 2 divided by -4 minus 2. That's going to give me -3 over -6. So this line A has a slope of 1/2. If we look at line B, again, my y values are -3 and 1. My x values are -5 and 5. So we're going to end up with a -4 over a -10 to give me a slope of 2/5. And if I look at line C, we're going to go with -3 minus a -1 over -2 minus a 2. We end up with adding the opposites, so that ends up with a -2 on top. And we're going to end up with a -4 on the bottom, so that gives me 1/2. So that means that A is parallel to C. Okay? So again, that's why this is super labor intensive, just because we're going to have to find a slope 3 different times, which I can honestly say isn't very fun. But it is what it is. So we're going to go with 5 minus 1 over negative 2 minus 2. So we're going to end up with 6 over negative 4, which is going to be me a negative 3 halves. Again, I don't know where to squeak all this in. I did A, so let's look at B here. So here's line B. So 3 minus 4 over negative 4 minus 3. So we're going to end up with a negative 1 over a negative 7. So 1/7 is my slope there. And then in C, and I realize I am rolling fast, but you have the option to click pause to catch up. So that's why I'm just going to go ahead and roll hard. But there we go. Uh-oh, something happened here. Did we get none of them parallel? You know, it could be a possibility. Or I made a mistake because I'm going too fast. So let me quickly go over this and see if I do have a mistake somewhere, because we wouldn't want that to happen. Oh yeah, see, I can't. Well, not that mattered. 5 minus 1 is going to give me a 4. But negative 2 minus 2 is also a negative 4, so this is actually a negative 1. So irrelevant, none are parallel. Man, all that work and then tell us none are parallel. That's no bueno. All right, so we also have to do the same. So we have to do that in a couple of different situations. So we have we have points. We could also have the equations of lines. So in line A, I've got to get y by itself. So I'm going to write this as, so line A, we're going to rewrite that as negative 3y is equal to 4x plus 9. So wrong answer again. All right, get in a hurry. It's 4x minus 9. So we're going to subtract the 9 to the other side. And now we're going to divide out that negative 3. And the only thing I'm after here is the slope. So even though I divide everything by negative 3, I'm only worried about the slope, which is going to be negative 4/3. Okay, if we look at line B, we are going to, all we have to do is divide by 8. So that means in line B, my slope is negative 6/8, which reduces down to negative 3/4. And finally, for line C, again, the only thing I have to do is divide by 4. And the only thing I'm worried about is going to be the negative 3/4 for a slope there. So that means that B is parallel to C. Second verse, same as the first. We're going to come over here. We have to solve for y. So in some of these, it's going to be labor intensive, meaning we're going to have to add the x over and get x plus 4. We're going to divide by 5, divide by 5, and divide by 5. So this one has a slope of 1/5. We're going to divide by 5 and divide by 5 and divide by 5. So that means it has a slope of 1/5. And we're going to add the 2x over. And you know what? I know I'm looking for the slope. Well, I'm going to write it out anyway. The slope here is 2/5. So that means that A is parallel to B because they have the same slopes. Okay? So one skill we have to do here is we have to be able to identify lines that are parallel. Part 2 of this is we have to be able to find the equation of parallel lines, meaning write an equation of a line that passes through the given point and is parallel to the given line. So again, I'm going to use point slope form. We're using y minus y1 equals m times x minus x1. That's the point slope form that we're using. So we're going to go with y minus a negative 1 equals. Now here's the part that I was not given. I was not given a slope, and I need a slope that I can make this work. However, I know because this is parallel, my slopes are going to be the same. So that means I'm also going to use 1/3. And then x minus 3. So that gives me y plus 1 equals 1/3 x minus 1. So I'm going to subtract the 1 to the other side. And so my equation is y equals 1/3 x minus 2. If I come over here and do the same thing with number 8, okay, y minus a negative 2 is equal to, again, I have to get a slope. Because they're parallel, the slope is going to remain the same. So that means my slope is going to be negative 2. We're going to subtract the 2 over there. Y equals negative 2x. And then the 2's cancel to give me minus 0. So that was working with parallel lines. Okay? Now we're going to do the same thing with perpendicular lines. Okay? Determining which ones are perpendicular. So again, we're going to go through that same exact process we did on the previous ones. We're going to have to find the slope. Line C, it looks like that it goes down 2 and over 1. Line B, it looks like it goes up 2 and over 2. And then line A, where's the 2 points for line A? I don't even see them. There they are. So we're going to go down 1, 2, and 3, and 4, and over 2. So it went down 4 and over 2. So we're doing parallel or perpendicular here. All right, we're doing that up there? No, I just said parallel up there. So this is parallel or perpendicular. So in this particular example, because this simplified into a 1, our only solution here is that A and C are parallel to each other because they ended up having the same slope, because that's a negative 2 over 1 when we simplify it. Again, we can look at these and determine the parallel and perpendicular probably. It looks like, I don't know which one it looks like. Which one's more perpendicular? I think, just looking at it, A and B appear to be most perpendicular, but here we go. B, I'm going to go down 1, 2, and over 1, 2, 3, 4, 5, and 6. So I went down 2 and over 6, so that had a slope of negative 1/3. If I look at line A went up 1, 2, 3, 4, 5, and 6, and it went over 2. So it went up 6 and over 2. So that means it had a slope of 3 over 1. And then down here, if we're going to find line C, we went up 1, 2, 3, 4, and 5, and over 2. So it went up 5 and over 2. So there's not a whole lot of slope we can deal with there, but I am looking for, again, since this is 3 and this is negative 1/3, they are opposites, positive, negative. They're reciprocals, 3 and 1/3. So therefore, we can say that, my gosh, what was this? A is perpendicular to B, okay? Again, we're looking for those opposite and reciprocals. So now we're going to do the same thing, except we're going to do it with, again, it's that same process. Does it say 9 through 14? So we're doing parallel and perpendicular within the same exact segment, okay? So we're going to do the slope for line A, which is going to be 4 minus 1 over negative 2 minus 1. So we're going to end up with a 3 over a negative 3 or a negative 1. For B, again, my y values are 1 and 4. My x values are 2 and 4. So I end up with negative 3 over a negative 2, so that equals 3 halves. And then for line C, in line C, we're going to have a negative 2 minus 4, and that's going to be over 1 minus a negative 1. So we end up with a negative 6 over a 2, which is also a negative 3. And again, I don't like the feeling of this. I feel like I made a mistake because it turned out that we have nothing is parallel nor perpendicular. So I'm just making sure that I didn't make a mistake real fast. Okay, so in this case, neither are parallel or perpendicular. All right, going on to number 12. Again, we got to find the slope for line A. I don't like that notation. Oh, there we go. Anyway, A. -4 minus -1, that's my numerators. -2 minus a -1 is going to be my denominator. We're going to end up with -3 over -1, and so that ends up with a 3 for a slope. In line B, we end up with -4 minus 2. We end up with -1 minus 1. We end up with -6 over -2, which is going to give me a 3. And then we also have C to do. We're going to have 3 minus 2 over 2 minus 4. So we end up with 1 over -2 or -1/2. So we're going to end up with A parallel to B. Again, we're comparing slopes. So we need the slope of line A is going to give me 3/4. We're already there. We're going to divide by -3. So the slope of this line is going to be a -4/3. We're going to divide by 4. So we don't actually have to rewrite the equation. I am just worried about the slope. So there's the slope and there's the slope. This one's going to be -3/4. And again, we are looking for opposite reciprocals. So that would be this guy and this guy are opposite signed, and they are reciprocals of each other. B and C are reciprocals, but they're not opposite signed. So in this case, A is perpendicular to B. And moving over to 14. Again, this is a little bit on the ugly side as far as we need to add the 2x over. We're going to divide by 5, divide by 5, and divide by 5. So this has a slope of 2/5. This one has a slope already. It is going to be 5/2. This one already has a slope. It is going to be 2/5. Okay? And, again, this is a really odd, but nothing is parallel nor perpendicular. Okay? That's where we're stuck at. So, again, this is all very, very much similar to each other, except now we are going to be given perpendicular is what we're after. And so that's what we're going to have to pay attention to. So let's just talk about slopes first. Here my slope is 2/3. So that means my perpendicular slope is going to be, if that 2/3 was positive, now it's going to be negative. It was 2/3, so that means it's going to be 3/2. So the slope I'm going to use is -3/2. Let's do the same thing for this one. So we're going to have to divide by 2 first. So that means the slope here is 2. So that means that my perpendicular slope has to be opposite, so it's going to be negative. It has to be reciprocal, it's going to be 1/2, and so that's the slope that I'm going to use. But the rest of this remains exactly the same. So y minus 2, because that's my y value, equals 2, we decided that we were going to use -3/2. I get in a rush. X minus a -2. So we end up with y minus 2 equals, I am going to distribute this. So that's -3/2 x. Then I'm going to add the opposite there, so I actually end up with another negative sign. My 2's cancel, so we're going to have 3. We're going to add the 2 over, so that means that y equals -3/2 x minus 1. Moving over to 16, the last one. Y minus 1 equals, we said over here our perpendicular slope is -1/2, and that'll be x minus 3. So y minus 1 equals -1/2 x, and that'll be a plus 3/2 when I multiply those together. We're going to add 1 and add 1, so y is equal to -1/2 x, and 1 is going to be the same thing as 2 2's, so that means I have 5 2's total, 5/2 total. So there we go. I know I have 4.4 in the notes here, but it's just one of those time things where I don't think it worked out well for what I want to do. So it's not going to be the end of the world if we didn't get to it. So we're going to skip 4.4. But that is our nutshell version of notes. So I hope you get something out of that. So.